Students, in today's class, in the previous class, we were discussing that the conclusions that we can draw from the CR circuit, okay, and we have calculated the value of your phase angle theta that we have calculated from the two equations. The two equations was there in your derivations, so we have taken the two most important equations and we have calculated the value of theta. All right. So now students, what we did till here, I'm just telling you in short that in the case of this purely resistive circuit, the phase difference is equal to 0 degree. That means your theta was your 0 degree in the case of your purely resistive circuit, isn't it? And in the case of this purely capacitive circuit, your I, that means your current, always leads the voltage V by 90 degree. Theta equals to 90 degree, that's why I've written. So students, in the case of this present CR circuit, that means for this one, okay, what you can conclude? That your I, that means current, should lead the voltage by this. Okay, that means combining both these equations, both these values of phase difference or phase angle, we can able to write this, that the current always leads the voltage by this. Okay, that means theta's value will be less than 90 degree, but it will be greater than 0 degree. All right. Okay, so now students, this was your conclusion number 1. Let's see what other conclusions we can get. Now students, we have taken the value of z, isn't it? If you just go to your derivation, what is the z? I told you all that z is the impedance of the circuit. All right, and z plays the same role as resistance R in the case of this purely resistive circuit. Okay, that means Z is doing the same work what your resistance used to do in the case of the purely resistive circuit. Okay, so this Z is known as your impedance of the circuit. Told you all many times in the previous derivations. So I'm just writing the value of Z again here. In conclusion number 2, this was your conclusion 1. Okay, I'm writing here as 1. So Z equals to 1 by R square plus 1 by omega c whole square. Okay, and I can write it here in this way. Okay, so yes, so what I did students, just this was your value of Z, the impedance. So just I've written R square plus XC square. XC means your 1 by omega c, that is the capacitive reactance. Okay, yes, so capacitive reactance value is 1 by omega c. So now students, what exact definition that you can draw from this here, from this part, what is the definition of this impedance in the CR circuit? What is the role of this impedance in this particular CR circuit? So impedance in a CR circuit is the effective resistance, you can see, that is arising from the combined effects of both this ohmic resistance and the capacitive reactance. That means here students, from this part. Okay, due to this, that means impedance that is being generated here, okay, whose value is 1 by omega c, is arising due to the effective resistance of the circuit from the combined effects of this ohmic resistance, that means from this R part, that is your ohmic resistance part, and the capacitive reactance. All right, yes. Now students, I can draw one impedance triangle, like in the other circuits also I used to draw the impedance triangle. So let's draw. I'm putting it here. Okay, this is your resistance on top that I've written. it is they are having one phase angle theta. Here is your impedance Z, and on this part you are having this 1 by omega c. Alright. Yes, students. So, these two conclusions we can draw from this particular derivation for the CR circuit. Okay. Now, students, let's find out the power in the circuit. Okay. Power in the circuit. Okay. So now, students, hope you have remembered the power factor, isn't it? So from this particular students, from this impedance triangle, we can able to find out the power factor. What was your power factor, students? I'm just telling you in short. Okay, that what is the power factor? The power factor, the factor cos theta, that means the cos theta part is your power factor in an AC circuit. Alright. So here students, in this particular part, that means in this particular impedance triangles rather, if you just consider it, you can see that your cos theta's values is coming as R by Z. I'm writing here cos theta equals to R by Z. Okay. So now if you just consider the equation for your power, okay, what equation that we used to take to calculate the power, students? I'm writing here P equals to half V naught I naught cos theta. Alright, yes. Now students, let's see in which form I can write it. Okay, now students, I can put the value of cos theta here. Okay, so I'm writing it half V naught I naught okay. So yes students, yes, so I'm writing it here. Just a minute. Yes students. So for this V naught, students, I can write it I naught Z. Okay, let me write this equation, then I will explain. Alright.